Hello, everybody. Good night. It's a great pleasure for me to be here at Justice Birth, first time in Romania, of course, first time in Bucharest. We're trying to chase vampires the whole day. We didn't find any yet because they told me maybe they're in Transylvania. We're a bit far, okay? So that's why we didn't find any. And and luckily for me, Bird just did a wonderful introduction about microservices, so I'll be able to skip some basic topics. But I'll be talking about microservice evolution, breaking your monolithic database, because we've been talking about microservices yeah, for a long time. And the number one question that I always received in any session and any conference that I presented was, but I still have a monolithic database and I want to be doing microservices. So how do I split my monolithic database or my monolithic code base into a microservices code or a microservice database? So I'll try to answer some of these questions. I've been researching this subject for quite some months, and I'm also writing a book about this topic. So I hope I'll be able to give to you or at least introduce you some useful tips for you if you're thinking about developing some microservices. So my name is Edson Yanaga. I'm a director of developer experience at Red Hat. My Twitter handle is @Yanaga. I'm also a Java champion and a Microsoft MVP. And I know it's such a weird thing to be, but it shows how the world has changed. So some years ago, it would be something impossible, but now I've been granted these two titles, and I'm very happy for them. But basically, I've been doing some Java stuff on Microsoft Azure. So that's why they awarded me the Microsoft MVP, so Microsoft and Java on Azure. So that's the weird part of the things. But just to show you how the world is changing, I like to always like to introduce my sessions with this sentence. Now every company is a software company because you don't work for a bank, you work for a software company. You don't work for an industry, you work for a software company because software is changing the world. Software is the thing that is changing modern economies, this new digital economy where everything is software based. You know, we know that software can make the people's lives wonderful, but we can also make them miserable because we're users too. When we don't make the software that is up to the demands of our users, when we use crappy software, we know that miserable feeling that we have. But we also can have that wonderful feeling of doing great stuff and looking that the software that we do can change the people's lives for the better. So I believe that we can choose to make people's lives better. And that's why I believe so much in software. And that's why I love so much to work with software. Some of the great examples of this new digital economy is that the largest car transportation company in the world owns no cars, which is Uber. The largest lodging company in the world owns no real estate, which is Airbnb. The largest online retailer in the world owns no stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. All of these companies have something in common, is that they only exist because of software. And we know many other different companies and software business are going to rise because of software. So we are the most important people on the planet from now on. We have this privilege of being software developers, and we can do much better because we can make software that change people's lives for the better. There's some of the things that I truly believe about software development. And since we're talking a lot about DevOps and microservices, Bert talked a lot about DevOps and microservices. I always like to talk about why we should be using DevOps and microservices. So imagine one of the main reasons for being using DevOps and microservice techniques is to improve your feedback loop as social. What am I screwing? Too much, okay, I need to stand still. Okay, so not move, not shake hands. So if we're talking about the feedback loop, we, we know we humans as social animals, we need the feedback loop to keep improving the things that we do. That's how we learn how to talk. Yeah, we needed the auditive feedback and our parents and grandparents' feedback to know if we're making the right sounds or we're trying to code. We want the feedback loop to see. Okay. Okay. But I don't mind holding the microphone. Can you hear me? Yeah, okay. I hope the guys online can hear me too. So when we're talking about the feedback, look, we need this because when we're coding, the faster that we can see the result of our code, the better code that we do. We know it does. If it takes too much time for us to code and to check that thing in production, the quality of the software that we deliver is worse. So even for business people, if we can happily, quickly test the hypothesis that we have, I don't know if I change the color of the bottom to orange, maybe I'm going to sell more, but sometimes it takes 6 months to deliver down to production. So everything that the guys thought about when changing the color, he doesn't remember anymore. So that's why sometimes we have to hear things like, I don't know why they're asking this thing. They don't even know why are they asking these features. Why? Because we take so long to deliver, and sometimes many of the things they ask us for us to do doesn't make sense anymore. So we need to improve the feedback loop. And imagine, we have many different, we have just one feature to develop. We have one hypothesis, and we want to deliver that into production. And sometimes it's hard to know if we're doing the right thing or if they're doing the thing right. So that's the two biggest challenge of software development. We need to know if they're doing it right and if that's the right thing. So we have too much doing at the same time. It's hard for us to test because when we blow things up in production, it's hard to know which part of the code that we changed that caused the bugs into production. So imagine maybe if you could reduce the amount of things that we do each one of these times. So in each one of the releases that we put into production, instead of having like 1,000 lines of different commits into production, maybe if you could reduce the amount of things that we do at a given moment, at a given release, so that each one of these releases could be smaller and smaller and smaller, so that when things blow up into production, we can quickly access and know which part of the code provoked that bug. So naturally, when I know it happens a lot when we're talking about DevOps and we have bugs in production, because in all of the companies that I've visited before as a consultant, it happened a lot. We have too many bugs into production. What are we going to do to prevent these bugs? We need to do more testing. So instead, now we're releasing once a month. Now we're going to take 2 months to deliver software to production because we need more time for testing. But people don't realize that the more time that you wait, the more code you're going to have to release into production, because you're going to have to develop more features, and there's not always not enough time to do the appropriate testing, so you just keep hitting bugs in production. So the right way to approach this problem in DevOps is, instead of delaying your releases, you should be doing more releases. You should be releasing more often, because I always like to do this very simple correlation. I like to say what causes bugs into production is code changes. You also have environment changes too, but I'll try to simplify that. So what causes bugs into production? Code changes. So let's try to do a very simple correlation. The more code changes that you have, the more bugs into production that you have. So to solve the problem, what you have to do? You have to reduce the amount of code changes that you put into production each one of these times. So ideally, if we can reduce the amount of code changes that we deliver into production to a very small amount of lines of code, just a single commit, a small commit, just like 10 lines of code. If you take that 10 lines of code and deliver into production, if anything goes wrong into production, where is the problem? Okay, that's exactly on that 10 lines that you did, so it's easy to spot the mistake, it's easy to fix that. So when we're talking about DevOps, we need to improve our feedback loop by reducing what we do in each one of these releases. And technically, in DevOps terms, we call that the batch size. The batch size, the amount of things that you deploy into each one of the releases that you do. And ideally, the batch size should be one commit, one deployment. And maybe not everybody has to be Amazon, Google, or Netflix to be doing like Amazon. I believe it does one deployment each 13 seconds. Yeah. I don't think we have that many people to be deploying each 30 seconds, but and maybe once a week is okay for you, because you will not be coding that fast. If typing was an issue with software development, we just needed faster typers. But since we need to think about it, sometimes it takes a bit to get our ideas into code. So maybe for most of the companies, 1 week is okay, 1 day is okay. But we always have to aim and try to reduce the batch size. But even when we try to reduce the batch size, we have this problem called maintenance window, because sometimes we don't get to choose when our code's deployments, and that's one of the excuses that people do for not deploying more often, because you know that ops guy decide when my code is going to production, and maybe my maintenance window is just once a month at midnight on a Saturday. Okay, I don't know why they want to do that on Saturday, but okay. Yeah, that's just once a month on a Saturday. So even if we are able, even if we're ready to be deploying more often, the maintenance window exists and we can only deploy at that time. And the reason for having a maintenance window is because business requirements force us to not have downtime to our users. Because why we do that on once a month on a Saturday night? Because that's the only possible moment where our users are not using our software. So that's when we have to deploy. So it implies that we have this conception that um, releasing software into production implies in downtime. And to prevent that, to be able to release more often, we need to do some zero downtime deployments into production. For that, uh, we have this concept of blue-green deployments. Basically, it means that you have to duplicate your infrastructure. So if in any time of the moment, you always have two separate deployments working at the same time. So we'll be able to do some very interesting things, like all of the requests usually are going to a blue deployment. Then we need to add a proxy in front of that, just a load balancer or something like this. Then we would be able to have another deployment, so just a blue and a green, so they're both handling requests at the same time. Then if you want to update our software, we're going to first take the green out of production, update that. When it's ready to handle requests, we can put it back on the cluster. Then we get the blue out of the cluster. We update the blue. Then we put the blue back. So then we can have two separate deployments running to production. We can do that for scaling purposes. We can do that for high availability. But for our use case, we're going to do that specifically for providing us zero downtime. Because if we were able to do that, and if we take some precautions in the way that we develop our software, we'll be able to do these upgrades in our releases without disturbing the user. So ideally, none of the users are going to have or are going to notice any downtime in the backend software. So that's our aim. So once you have zero downtime deployments, just like using blue-green deployments, you can be allowed to do deployments in any moment of the day. And again, ideally, multiple times per day, because you're able to deploy into production. Oh my God, there's a bug. You can quickly fix it, and you can deliver that again in production. So usually companies that are able to do zero downtime deployments with blue-green deployments, they don't even think about a rollback deployment. Oh, something went wrong. I need to go back to the older version. It's much more easier when you have a sophisticated and quick response time, a feedback loop. It's much easier to fix the bug and deliver a new release rather than rolling back your release to a previous version. So that's blue-green deployments. Much as usual, I'd like to say the code is easy and the state is hard. It's easy to update code into production with zero downtime or anything else, but state is always hard. And the state, when I say state, you can have ephemeral states, just like session states where you can hold that in memory. And even if you lose ephemeral state, the worst case that you can have with your users is to require them to log back again or use some shopping cart. It's not much disturbance. But when we're talking about persistent states, just like in a database, it's not that easy, because when we're deploying to production, sometimes you have to alter the schema of the database. And usually it makes that one version that you're deploying is incompatible with the previous version of deployments. So you can't have two versions working in parallel. You can't have a blue-green deployment when you have different schemas between one of these versions, and it always implies downtime. So the problem that we're trying to solve here is, how can I upgrade my database into production with zero downtime? And we have some techniques for that. That's zero downtime migrations. And then when talking about migrations, that's the technical term for your outer table statements that you have to execute between one version and the other. And we have some very impressive tools that can automate that for us in our DevOps pipeline, just like FlyWayDB or Liquibase. Liquibase is a very old one. FlyWayDB for now is my favorite, but then right now they're feature equivalent. So there's no point of choosing one of the other rather than taste. They need to be, my migrations need to be back and forward compatible. And for that, we need to do these migrations in baby steps. In baby steps, I say the smallest possible batch size. And for many of our scripts, it's going to be, if you used to do big alter table statement script to update your database. That means that now your batch size is just one statement. You're going to do in each one of the releases that you're going to deliver into production, it's going to have just one alter table statement or maybe one update statement, one per deployment. It might sound like a lot of work, but in fact, it's much easier for you to be deploying this way. You'll be able to check later. So, and if you get, sometimes we need to update the rows in our database. I change the format or the type of database. I need to change the value that is stored in my columns. So when we issue an update, we have another problem because some database, they imply into a write lock when we're doing an update in the database. And if you have too many rows, it's going to take a long time. Sometimes it takes like 2 minutes, 5 minutes, 10 minutes, depends on your database. And it means downtime. You're not allowed to have such a downtime when doing zero downtime migrations. So the answer for that is you need to shard your updates. And then when I say sharding, you're going to split your data set in a certain amount of rows that you can update without a zero downtime. At least with a reasonable downtime, like 1 second, 2 seconds, what's reasonable for you. So if I have a 5 million table in my database, I'm going to update that like 100 rows at a time or 1,000 rows at a time. Depends on the speed of your data and anything else. So we're going to shard our data. And for that, some of the refactors that, in fact, it's not a refactoring, but a restructuring because we're changing structure. Refactor implies that you're not changing the result of the things, but here is a restructuring. So instead of just doing alter table, rename column for something, we're going to have to add multiple steps in our alter table statements. And each one of these lines are going to be in a different release. So we're going, instead of just renaming a column, we're going to have to add a new column. We're going to update the new column with some shards, with using where statements. We're going to do a code update, maybe another code update, another code update, so that we can later, or much later, we can finally delete the old column, so everything goes right to production without zero time. I'm going to show you some of the techniques that I've been collecting in the past few months. So some common scenarios for zero downtime migrations are I need to add a column, I need to rename a column, I need to change the type or format of a column, and I need to delete a column. That's if you think about a table as a set of columns, you can apply all of these restructuring patterns into your table too, just applying that multiple times in sequence. So there's not big issues using tables. So first, to add a column, the simplest possible scenario is to first I add a column. Second, I can add a null or default value or a computed value for my new column. And then third step, I can use the column in my code. So to be able to add a column in a database and in my code base, I'm going to create a release of my software, adding a column to the database. The second release is going to compute the value. If I'm going to compute the value, it has to be sharded. It's going to take a long time. And then the third release, I'm going to use the column. Another pattern for rename a column, I'm going to do at least 6 releases. I'm going to add a column to the database. I'm going to copy the data using small shards, and it can be multiple smaller steps depending on the size of the data. Third, I'm going to create a new code in a new deployment. The code reads from the old column and writes to both new and old columns, so you can have backward compatibility. If you get the new release, oh, something's not working, you can roll back the data is still there. Step number 4, oh, and between step 3, 4, and 5, you can always check manually. I release into production. Is my data being saved correctly in the database? You can check manually, or you can check that automatically. It's up to you. And step 4, your new code reads from the new column and writes to both, because you need the old data in case your deploy goes wrong. And finally 5, your code reads and writes from the new column. So, and then some days, weeks, or months later, you decide to do a cleanup in your database, you can finally delete the old column because now you're sure that the old column is not being used anymore. Of course, if that's a non-null or default value, maybe you will be wanting to still be saving the value so you don't break the constraints of your table or anything else. So that's the basic pattern of renaming a column into production using zero downtime migrations. And you see, The next strategy is to change the type of format of a column. You can see some similarity here. That's always the same steps. Doesn't matter what you do. So, oops, renaming a column or change the type or format of a column. It's always the same steps. You apply the same refactorings because you never execute a destructive statement. You just add a new one. You start to use the new one. You copy the data. You start using the new one. Your code needs to write to both always until you are sure that that your new code is working properly. Then you can delete the old column. That's how you do non-destructive zero downtime migrations that will make you able to be deploying in any moment in production, ideally during the day, so you'll be able to quickly fix the bugs and correct them into production again. And the final restructure is delete a column. The tip is don't. You never delete a column to production because that's a destructive statement. If you delete a column, the only way to resolve the bug that you had into production is to get the backup and restore that, and it might take like some hours. I did it a couple of times already, when you try to deploy and something goes wrong and the backup takes 8 hours to go back into production. You have some pissed off customers calling your phone. So just don't. When you have to delete a column, just stop using the read value, but keep writing to the column because you don't know, you're not using it anymore, but maybe you need to release the version, you still need the data. So you just stop reading, but if you have to write something, you still write the column until it's not needed anymore. And some releases later, you just decide that you can delete the column and it's okay. It's safe when you're doing like once a month or once every 2 months. You can delete all of the old columns that you're not using anymore. And of course, you're keeping tracking of the things that you're not using anymore, or else at some point of the moment, you have just unused columns. And what about my referential integrity constraints? There's nothing implied in my database structure about the referential integrity constraints. It's just something, a safety net that we put in your database. So the simplest possible answer is just drop them and just recreate them when everything is working correctly, because you shouldn't rely on referential integrity constraints for the correctness of your domain model. It's just a safety net for you. You shouldn't be using the safety net into production. Again, it's just a safety net, so it should be safe for you to be releasing and dropping and recreating them. Okay, that's how you do microservices, zero downtime migrations in your database into production, because now we're talking about multiple microservices. You won't be the guy or girl wanting to deploy and release all of your microservices once with zero downtime to know if anything went wrong. So you want to be doing these zero downtime deployments into production with databases. But now it's the hardest part. I have a monolithic application with a monolithic database. I need to extract my code base into a microservice, or I need to create a new one. But I still need the data that is inside the monolith. How do I extract the data, particularly the database, the tables and columns that are still in my monolithic database, into a microservice database? So, because the best practice about microservices is one database per microservices. So each one of my microservices should have one separate database. But sometimes the typical scenario that I have is I have a monolithic application and a monolithic database. Everybody is accessing every one. So if I want to generate a report or access some information, I just use join tables and I have the information that I want. So how do I split them? I still have usable functionality. How do I take my monolithic database and my monolithic application and I still have my microservice working? The answer is that for some moments in the time, it might be a long time, you will have your monolith and your microservice accessing the same data in the same database, and maybe you'll be able to restructure your database and your application to be extracting it one step at a time until you have this fully separate microservice database. And for that, I'll have to explain to you some basic concepts about our software architecture, CRUD and CQRS particularly. So I think everybody, or at least most of you, must be aware of CRUD, which is a very popular architectural pattern. And everything about architecture is always a trade-off. You have advantages and disadvantages. CRUD is appropriate for some use cases, inappropriate for others. So CRUD, you have the create, retrieve, update, and delete, and I'll try to explain to you in a very simple terms, because you have a lot of reference in the internet trying to explain to you what is CRUD and what is CQRS, and they're very hard to understand. I'm going to try to explain to you regarding to database, what does CRUD and CQRS means. CRUD means that the create, retrieve, update, delete operations, they are all executed against the same data store, in our case, the same database. Same tables, same columns, same everything. You're reading, writing, updating, and deleting everything from the same database. That's CRUD. Okay? Theoretically, in architecture terms, you're using the same model to be updating, creating, retrieving, updating, and deleting. And when we're talking about CQRS, it means that command query responsibility segregation. We are talking about database, it means that your write operations are executed against a data source, in our case, a relational database, and the read operations are executed against another database. Example, for that, if you have a customer entity, you're gonna create, retrieve, update, and delete the customer using the same model in the same tables. So customer, at least for us, a very simple use case. It's a typical CRUD operation, but when you're talking about like money in an account, we could be using CRUD, create, retrieve, update, and delete the same table, but that's not a safe thing, because anybody would be able to issue updates, account, set amount to something. So that's not a safe thing for using monetary values. So what we're trying to do is that we're going to separate the write and read operations. So we're going to have an entity called an account, which represents the account, and the state of the amount of money that I have in my account is going to be represented by another table called transactions. So this state, everybody has the same initial state: zero, zero lace, zero lace, okay, which sounds funny. Zero lace, zero lace, and we're gonna. So everybody starts with zero lace, and you add 10. You subtract 20, you add 50, so you have multiple transactions. And since it's a deterministic system, if you apply the same transactions at the same sequence, every time you're always going to get the same result, right? So the state of your information is not stored in a column in a database, but rather the state is represented by the stream of things that happen into that account. That's what. So the write operations go to the transaction, and the read operations are done someone else, because it's very consuming to be calculating the amount that you have in your account by replaying the transactions every time. So you might want to cache this information so that it can be easily reading into any given moment of time. So you're gonna save, you're gonna add a column called amount in your account table, but just for caching purposes, because the real write operations are written in the transaction record. And you have built-in auditing when you do that. You have logging and auditing. So you have many benefits when using CQRS, but you have much more work. So when you're using CRUD or CQRS, is always a matter of trade-offs. So you got to be wise. But usually things that have some, you want to know how much you have at a given moment of time. Usually things that you can add and subtract, you use CQRS, and plain old entities, you can use CRUD. And some scenarios for creating this separate database, this separate microservice database that can coexist with the monolith application during some time. Sometimes are using a view, materialized view, mirror table using trigger, mirror table using transactional code, mirror table using ETL tools, and event sourcing. Usually event sourcing is the last step, less restructuring. Usually it's also the ideal thing, because if you want to have true CQRS, you're probably going to use event sourcing too. I want to, I have a separate code base, a separate microservice, but I still need information that is in the monolith. How do I access that information? The easiest and possible, simplest way is using a view. So view is the easiest one. It also has the largest support between databases. It has some possible performance issues depending on how you create a view, both on your microservices and your monolith. It has strong consistency, and I'm going to explain to you what is a strong consistency and eventual consistency. Strong consistency means that in any given moment of time, if two different clients issue a read request against a system, they're both going to get the same value. Okay, everybody gets the same value in a given moment of time. And to eventual consistency, it means that different clients at a given moment of time, they might read different values, but eventually the value will converge to the same time. So the clients are not getting wrong values. They are getting old values, but eventually, in any given moment of time in the future, they are all going to get the same value. Okay? That's eventual consistency because eventually all of the clients will have the same value. So strong consistency, you guarantee they're all going to get the same value at a given moment of time. Eventually they'll get the same information. I can't allow my system to have eventual consistency, but when we're talking about banks and somebody deposits some lace in your account, it doesn't show up automatically in your account. It takes some seconds, takes some minutes. So banks use eventual consistency. So maybe you can use that too. Why? Because eventual consistency is much faster in terms of performance. So the view, it has a strong consistency. One database must be reachable over the other. If you're using Oracle, you can use DB links to make one database reachable even if they're remote systems. And depending on the database that you use, it can also be updatable. You can create a view that is updatable, so you can issue write requests on your view, and they will reflect on the original table. Okay. Materialized view has much better performance than view because, in fact, it's implemented in the background by the database servers as a real table. It can have stronger eventual consistency, depends on the database, depends on the requirements, and depends on how you create your materialized view. One database must be reachable by the other. You can use DB-Link too, and it may or may not be updatable depending on the database and how you implement that. So it also you can also issue write requests on a materialized view if your technology allows and you create it the right way. You can also extract your data using a mirror table, using a trigger. Triggers depends on database support on what you want to do. Trigger is also strong consistent because you execute the statements on the same transaction. One database must be reachable by the other, and you can use DB links, even though some people told me that this approach usually doesn't work very well, but it's possible. So it depends on how you're implementing that. Mirror table using transactional code, and when I say transactional code, it can be any code. It can be a store procedure, it can be a Java code, you can be using XA and two-phase commit protocols. It depends much on your technology, but you can use any kind of implementation that has distributed transactions can be used to be executing transactional codes. So if you're using transactional code, you have a strong consistency. You can be using store procedures, distributed transactions, or anything else. You might have some cohesion and coupling issues when you're using transactional code between that. So that's an implementation problem that you might have. And it can be updatable, again, depending on how you implement this approach. You can also create a mirror table using ETL, extract, transform, and load tools, most popularly known as BI tools. If you're thinking about BI, ClickView, or something else, BI tools are typical ETL codes. You have lots of available tools. It usually requires an external trigger because ETL tools, usually they are Chrome-based triggers. Every 5 minutes, every 10 minutes, every day, every night, or every week, every something. So it requires an external trigger. Of course, they can aggregate from multiple data sources. Since it requires an external trigger, it's always eventual consistent. And it's always also read-only because you are only extracting the information and saving somewhere else. And for now, maybe the most sophisticated one that you want to use when using CQRS is event sourcing. As I said before, the state of your data is a stream of events, just like transactions in a bank account is a stream of events. It eases auditing because you have built-in auditing when you model your application like that. It has eventual consistency because the transactions can be applied later by the clients. And for that, you need a distributed stream through a message bus. And for that, sometimes it's very hard for me to apply CQRS and event sourcing because if I have a legacy monolithic database and a monolithic application, I don't want to be changing the source code of my monolith because it implies a lot of work to be extracting my microservice, but I want to be applying CQRS and event sourcing. So one of the coolest projects that I've seen these years is a new project, which is developed by Red Hat, is Debezium. Debezium is from DB. The Ezium is just to sound like a new chemical element. Okay, Debezium. Yeah. And Debezium is the new cool project which has built-in support for CQRS and event sourcing. So you just take your existing database, you plug this guy into the database, it automatically starts listening for change, alter table, update, and start delete statements in your database. And it generates a stream of events that can be consumed by other clients. And you can get this stream of events and do what you want with these events. You can get this stream of events and replicate your table into another database. You can create a cache of information in another microservice. So it's a very flexible thing. And that's one of the things that I want to show you for now. So I have this cool demo that I want to show. How many minutes do I have left? Okay. So no, 10? Okay, I'll make it work. So I have running here. When we're talking about it, it uses Zookeeper for distributed coordination. I won't have time to explain Zookeeper. It uses Apache Kafka for this distributed event bus. Some of the cool things about Kafka is that it's persistent, it's ordered, it's reliable, it's lightweight, and each one of the clients can have an independent index, so they can consume the messages at their own pace. So that's one of the cool things. And I've plugged Debezium into a MySQL database that is running here. And here Debezium is running that is plugged on my MySQL database. So basically I'm gonna have here, I have a Debezium watcher that is gonna show me and debug the messages that are going through Apache Kafka. I have a MySQL client here, and here is just to show you the messages. So I have MySQL, and I'm gonna use my cheat sheet here. So first I have a table, let's see, customers. So I have some customers here, and you can see ID N, her name too, Anne Marie. If we issue a select here, you can see it's updated. Let's see how it goes on Debezium. Debezium generated an event, which is a schema event. I'm going to show you that format beautifully for you. Here, Debezium generated these events. You see in each one of the events, Debezium broadcasts me the structure, the table structure of the database. But the interesting thing for me, I'm going to get just the end of the event, the payloads. Before, my row has Anne Marie. So it just listened for events on my MySQL database, created and broadcasted that to the clients. So you can have the source, and the operation is you, because that's an update operation. And Debezium does that for each one events. You can be using the information. Oh, somebody updated the record that. I need to update that on my local cache. And you don't have to save the whole information, because maybe customer can be a big table. I don't want to be replicating the whole customer because here I'm just generating a report, and the only thing that I need from the user is its ID and the name. So I'm not gonna replicate everything with the address and phone number, everything else, because my microservice is just a reporting. Okay, it's a reporting microservice. So the only thing that I need to save in my microservice reporting database is customer ID and the customer name. So I'm gonna create like a kind of cache of the customer information for me to be able to generate my reports, because I won't be issuing REST requests. Everybody thinks about microservices, create a REST point, and everybody that tries that just realize that in production, REST are too slow. You always need to cache some kind of information locally to be able to execute performatically. So you're going to save this in your local microservice base using this information that Debezium broadcasted for you. We also use other kinds of statements. I can issue a delete delete. You can see Debezium create another 2 events. I can also show that for you. Debezium generates 2 different events for delete, just for performance issues, because you know, if the record is going to be deleted, if the customer has access to the whole stream, you got to insert, update, 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 and delete. If the customer can see the whole stream, then if the final one is delete, why are you going to apply the insert, update, delete if the final state is delete? So it does some optimizations. I can just create here a final payload of nothing because the record the record was deleted. I can also here, and one of the cool things here about Debezium, I'm gonna stop Debezium. Okay, I just stopped the Debezium. I'm gonna insert some values into my database. Insert customer, Sarah and Kenneth. I just inserted them. You see Debezium generated no new events because it was stopped. But what can happen? Debezium has to be reliable. So I'm gonna start the, oops, connect. I'm gonna start Debezium again. And it's gonna start again from the point that it has stopped. So when Debezium comes back up again, it just generated the 2 insert statements that happened while it was not running. So just get this one, get just one event. I'm gonna see here, you see Sarah, one of the records that I just added, Sarah Thompson, and that's a C operation because that's a create operation. That's some of the cool things that the Debezium can do for you. Thank you, Bert, for your support, literally. Okay. So Debezium is one of these cool projects that you can apply to your legacy database to just plug in with your existing database. Currently, it supports MySQL, MongoDB, PostgreSQL, and Oracle. PostgreSQL and Oracle, it's a work in progress, so we're improving the drivers too. And once it reaches 1.0, we're going to release that. 1.0 depends on Oracle and PostgreSQL fine support. So once it reaches 1.0, in MySQL it's already working. You can use that to plug in your database, into your monolith, start listening only to the tables that you want because you don't want to broadcast everything in your database. You're just extracting customers or everything. You can have a Debezium connector for each one of your microservices to listen for the specific parts of your schema. Each one of the Debezium connectors can listen to just a subset of the tables. So you can plug multiple Debeziums into your database, and you can broadcast and start using your microservices with your cached information, your replicated information into separate databases, so you can run your microservices effectively, and most important, easily, and without having to change a single line of code of your current database. Your monolith stays there. It just plugs externally. All you need is a user, okay, with access to your database. Debezium will connect and start broadcasting the events with Apache Kafka. So that's what I wanted to show you for now. Thank you very much for being here. We're just said about developers.redhat.com. We have a lot of software, articles, webinars, tutorials, videos. We're writing all of this stuff, and will be available at developers.redhat.com. And the book that I'm writing about these steps, it's going to be an O'Reilly book. It's going to be available for free, at least for the first 30 days, into developers.redhat.com. And we have a lot of different books written by Red Hat engineers available for free also. At this site, I would love if you have some questions or feedback about the subject, and you can reach me at my Twitter at Yanaga or Yanaga@redhat.com. And thank you very much.